Hello class and welcome to lesson 6.3b, transformations of sinusoidal functions. Last lesson, ladies and gentlemen, we used the graphing calculator, or the TI-83, to help us produce graphs to help explain the changes of A, K, D, and C. Today we're going to learn the key components, i.e. the amplitude, the period, the axis, the min-max, to help us draw our graphs without actually using a graphing calculator. So we're going to do it by hand today. So let's just remember, ladies and gentlemen, a couple things that we should have learned from last day. To start with, we have our period. So the period is 360 degrees divided by the absolute value of K. All right. Your equation of axis is that y equals c. Your amplitude equals the absolute value of A. Your max deals with a couple things. It deals with your axis, which is C, plus your amplitude, whereas your min is C subtract your amplitude. All right, and if we want to do range, ladies and gentlemen, just remember that y belongs to a set of real numbers such that your minimum has to be less than or equal to y, which is less than or equal to your maximum. Okay, we can substitute in our minimum values and our maximum values to make this more, more unique to sinusoidals, in that we know whatever it's going to be C plus absolute value of A, minus absolute value of A, because it's the minimum. So C minus absolute value of A to less than or equal to Y, less than or equal to our maximum, which is C plus the absolute value of A. All right. So again, that's things that we've been building on. These are all key tools we will use in the next couple of lessons to help us either deal with applications or to create equations from a graph, which would be next day's lesson. So these are key components that are specific to sinusoidal functions, and they relate to all of your transformations A, D, K, and C. You may be wondering, hey, Mrs. R, why is the D not on here? And the D, remember, is your starting value. Where you're going to start drawing your boxes, and we're going to talk about more about that today. All right, so let's start off, ladies and gentlemen, with a chart. Okay, and you should see this in your handout. Before we fill in the chart, ladies and gentlemen, don't forget, we always have to watch to factor out K, because some cases you can't, it's not factored out already. And in this case, if you look at the third graph here, we're going to have to factor out K when we get to it. Okay? All right, let's get going here. In order to help us complete our graph, let's realize that the equation of axis is related to what letter? Hopefully you know that's y equals c. Your max from last page that we just reviewed should be c plus the absolute value of A, whereas your minimum is c minus the absolute value of A. Your period is what we learned. It's 360 degrees divided by the absolute value of K. D is your starting value, so you look at D. And your end value, well, you got to take your start value and add your period. So it's going to be D plus 360 divided by the absolute value of K. All right, let's start off with something easy. Let's start off with a parent function, y equals sine x. So for y equals sine x, you notice there's no plus 3 or minus 5 after it, so that means c equals 0. So y equals 0. Your max and min, again, it's going to be amplitude of 1, so it's going to be plus 1 for your max, minus 1 for your min. For your sine x, again, we notice that k equals 1, so 360 degrees divided by 1 equals 360 degrees. Okay, and that is your parent function's period. Okay, our starting value equals 0 degrees. We're not shifting left or right to start with. And so when we start at 360, we've got to go 360. Sorry, we start at 0 degrees. We go to 360 to be our end value. So we're going to draw our boxes in later between the start value and the end value. So remember we did the dotted boxes? That's what those represent. All right, let's move on to a little harder example. Okay, looking at our second example, c equals 0, so therefore y equals 0. A is our max, and it's related to, so A is 1/2, and C is 0, so it's still going to be half, and negative 1/2. Okay, noticing our K value is still 1, so it's still going to be 360 degrees. Our start value, notice here, guys, that it's X plus 60, so that tells me that D has to be negative 60 degrees. So watch that, because remember, it's X minus D in the formula. Okay, and so if I start at negative 60 degrees and I have to complete it in 360 degrees, that's going to equal the end value will be at 300 degrees. All right. Taking a look at our next graph. Okay. Before we look at this, we should notice that, if I'm going to move this up a little bit so it's not in that box thing, you should notice here that we need to factor out K. Okay, so looking at that, how can you tell you need to factor out K? Because it's got 2x plus 90. So it's not factored out. So you're going to go y equals sine of 2 times x plus 45 degrees, and then minus 3. And I apologize, I need a second set of brackets in there. There we go. All right. Okay. Let's take a look here, folks. What do we have? Noticing that C in this case equals negative 3, so y equals negative 3. I apologize, I changed colors. Let me fix that again. So y equals negative 3. Okay. Our maximum is C, which is negative 3, and then we got to add our amplitude, which is 1. Okay. So when we're at the absolute value, so it's going to be 3 plus 1, that's going to negative 3 and you add 1 is going to be negative 2. And you take negative 3 and you subtract 1, it's going to be negative 4. Okay. To figure out your period, it's 360 divided by K. This time K equals 2. So that's going to be 180 degrees. Okay. Taking a look at D, D is going to be plus, it's positive 45, so that means we're going to start 45 degrees to the left, that's why it's negative 45. And if we're starting at negative 45 degrees and it takes 180 to complete one cycle, that's going to equal 135 degrees. Okay, moving along, next example. Okay, take a look at this. We notice that C equals 1, so y equals 1. Taking a look at 1, and then our amplitude is 3. So that's going to be 4 for our max. And to find our min, that's going to be negative 2, because you take 1, subtract 3. All right. Now we're going to find our period. So you take 360 degrees, and you divide by 5, because that's K. So it's 72 degrees. D equals 0, so we're going to start at 0 degrees, and if we're going to start at 0 degrees and it takes 72 degrees to complete it, that means our end value is going to be 72 degrees. All right, moving on. Next one, y equals cos 1/2 x minus 30 plus 2. So the plus 2 tells us y equals 2 is our axis. Okay, you're going to take 2 and you're going to add 1 to get 3, which is your minimum, because a equals 1. And then you're going to take 2 and subtract 1 to get your minimum, so a equals 1. To find out your period, this time you got to be careful, because 360 degrees divided by 1/2 means, remember, you invert and multiply. So it's really 360 times 2, which is going to give you a total of 720 degrees. Okay, looking at my D equals 30 degrees, so I'm going to start 30 degrees to the right, and I need to start there, so if I got to start at 30 degrees to the right, I know I need 720 degrees to complete my rotation. That means I'm going to end at 750 degrees. All right, next one. We notice that C equals 5, so that means my equation is y equals 5. Looking at my maximum, notice we've got negative a here, so the absolute value is 1. So you take 5 and add 1 is 6. Take 5 and subtract 1 is 4. K is 1, so that means we have 360 degrees. Okay, there's no D value, so we're starting at 0 degrees, and we're going to end at 360 degrees to complete one rotation or one cycle. All right, last one here, folks. Taking a look at this, we notice that our C value is -1, so our axis of symmetry is going to be y equals -1. Because A is 1 and our axis is -1, that means our max is going to be 0 and our min is going to be -2. Again, our K value is 1, so that means we have a 360 degrees to complete our period. Looking at our D value, it's 15 degrees. We're going to start 15 degrees to the right and take 15 degrees and you add the 360 degrees, so that's going to equal 375 degrees. Awesome. We're going to be using that. It's going to be helpful for us to take those things to help us draw our graphs in a minute or two. Let's just quickly remember what we do vertically with our cosine. So our cosine starts at our max and it ends at a max to complete one cycle. Okay? Unless, what happens? Unless A is negative, which means it reflects the x-axis. So instead of starting at its max and ending at its max, if it's negative, it's going to start where? It's going to start at its min, so it's going to go min to minimum because it reflects, right? All right, let's take a look at our sine x, or our sine curve. Sine starts at the axis and ends at the axis, and it goes up unless A is negative, okay? Then it'll go down first. Then go down first, as opposed to going. So then it's really going to go to its minimum first, as opposed to its maximum, which it normally does. All right. What I'm going to do is I'm going to show you on the next page. I'm going to show you the second and the third equation. So the third one and the second one in the next page. So I'm just going to show you what they look like, and then we're going to go through these two starred ones here. Okay, in the next page. So I already have them done for you just so you can see what they look like. All right, so taking a look at the first one, ladies and gentlemen, or the second graph, I should say. This is my second equation. Okay, so this is y equals 1/2 cos x plus 60 degrees. All right. So notice, ladies and gentlemen, the plus 60 means I've got to start my box 60 degrees to the left, because D equals -60. Okay? I know it's cos, so I'm going to start at my max. And because K equals 1, we're going to take 360 degrees, so I'm going to end at 300 degrees. Again, we draw these boxes so we can see what one cycle looks like, and then we just repeat it throughout. Okay? We notice also that because there's no C value equals 0, we know our axis is right on y equals 0. And we know because A equals 1/2, we're only going up 1/2. So here's your amplitude of 1/2, and here's your amplitude of 1/2 as well. All right, moving on to the second one. The second equation was the one we had to factor out, so let me just write it out here, guys. So we're going to go y equals sine 2 times x plus 15 degrees minus 3, sorry. Okay, let me fix that up. Good. So where do I start with this, folks? I start at my -3 because we're going to be graphing these today. So I'm going to put my axis in at -3. Okay, it's going to help me draw this. Okay, I know it's sine, so sine is where I'm going to start at my axis, but D equals -15, so I got to move over. I apologize. I wrote down 50, it should be 45. We're going to start 45 degrees from here. Okay, that's where my starting in my box is. And if I know K equals 2, that tells me that I have 180 degrees to complete my rotation. So if I take -45 and add 180, that's going to be at 135, which is my end point. I'm going to check that I've got my max and my min here. My maximum is -2. My minimum is -4. I have an amplitude of 1. And there's your graph. Okay, and again, with your sine curve, you start at your axis, go to max, axis, min, axis. All right, let's learn how to draw some together, ladies and gentlemen, and we'll see how we do. Okay, graph y equals sine 4x plus 2. State the amplitude, range, equation, and axis. We'll get to those. What I like to do, folks, is I like to set it up with what letters do we know here. First of all, looking at A. A equals 1. What does that tell us? Therefore, it tells us the amplitude equals 1. Okay? Taking a look, what else do we know? We know K equals 4. Okay? Remember that we know that a period equals 360 degrees divided by K. So divide that by 4. So the period's going to equal 90 degrees. That's going to help me discover my box. Okay, what else do I know? I know D equals 0. Okay, therefore I'm going to start at 0 degrees. Okay, and the last part that I need to do is my C. C equals 2, which is your axis of equations. So my axis is y equals 2. Okay, so far we've answered a couple of those questions. State the amplitude. We already know that equals 1. Sorry, 1. Okay, the range we're going to get after we draw it, we already know the axis, which is y equals c, so y equals 2. And we'll deal with the range after we finish drawing it. It's easier to take a look once we draw. So when we take a look at doing this, ladies and gentlemen, I'm going to draw a couple straight lines. Okay, I'm looking at my axis, and my axis is going to be at +2, so I'm going to draw my regular lines a little lower. Okay. So what I need to know is I need to know a scale. So for my scale, why don't I let this be 1, this be 2, and this be 3. Likewise, this is going to be -1 and -2. Okay. So before I do that, I'm going to get my axis in. I'll just use a different color here. Okay. So there's my axis. That's where I'm going to have my symmetry go about. Okay. All right, now we're going to set up our scale. So we know that we need to take it and be 90 degrees in order to complete one cycle. So I'm going to spread this out a little bit more because my period is a little bit shorter. Okay, so I'm just going to go, how about 4 blocks and 45? Another 4, 1, 2, 3, 4, and 90. Okay, so 1, 2, 3, 4, 135. 1, 2, 3, 4, 180. Okay. So -45. 1, 2, 3, 4, -90. 1, 2, 3, 4, -135. And 1, 2, 3, 4, -180. All right? So once you've set your scale on, and your scale is going to depend on what your period is, okay? So I decided to set that up because I need to know that I have to get one rotation of my sine curve in the 90 degrees. Okay? Okay? So for sine x, ladies and gentlemen, we know it's going to start at the axis. We're going to go up to, we got to end at our axis at 90 degrees. So what does that mean? At halfway through, we've got to have gone to our max and to our min. So what does that mean? Halfway between 0 and 45, I've got to get to my maximum, which is 3. And between 45 and 90, I've got to get to my minimum, which is 1. Okay? Because my amplitude is 1, right? So ladies and gentlemen, there is one curve, or one, I would say, cycle of this function. So I've just drawn one. I like to put the box in. That's our starting point, our end point. Okay? But we're going to continue that function. And so that every 90 degrees, we are going to have these cycles in. So I know I need to put my axes on. Okay, so we're going to follow the same pattern. We're going to go up and then back down and then back up. And then you can put an arrow at the end, follow the same pattern. Okay. And there is our graph, ladies and gentlemen. Okay. The last part we want to answer, I'll just do the domain as well. So the domain is such that x belongs to a set of real numbers. That's why you've got your arrows on both sides, because it continues. But when they ask for the range, ladies and gentlemen, I like to do that after I graph. So the range is such that y belongs to a set of real numbers such that, what's my minimum value? It's 1. Has to be less than or equal to y, which has to be less than equal to my maximum, which is 3. All right. Good. Let's try this next one, ladies and gentlemen. Okay. Let's start with our a, d, k, and c, but I also want you to notice what your base function is. So I'm going to start with cos x, because guess what? That's my base function, unlike the one up above, which was sine x, okay? So you might want to just quickly slip up here, because I forgot to put that on. That's probably the best thing to do, is to just put down base is sine x. So you know, okay? All right, so this time our base is cos x, and I'm just going to change colors so that it doesn't confuse you. Okay, so looking at this, ladies and gentlemen, what do we know? We know a equals -2. The negative tells us it what? Reflects the x-axis. Okay, but the 2 tells us the what? Amplitude. So amplitude equals 2. Okay, looking at k, k equals 1, because it's right in front of x is 1. Okay, therefore that tells us that the period is 360 degrees. It doesn't change. Okay, looking at d, I'll do it over here, guys. D equals -35 degrees. What does that tell us? That's where we're going to start. So we're going to start left, because it's -35 degrees. Oh, sorry, 30 degrees. Okay, and the last one, C equals -1. So that's our axis, guys. So our axis, our axis is y equals -1. All right? So we've got all the information we need to do. We're just going to start by drawing some lines first. Okay? Notice my axis is -1, so when I start by drawing my x and y axis, I'm going to do my axis up there. Okay, and then maybe I'll just do this right here. Okay? All right. Setting up my scale. If I use the same scale that I used before, I notice that I've got -1, -2, -3, and 1. Okay? Automatically, I'm going to draw in my axis, which is y equals -1. Let's see if I can use a different color here right now. So -1 is right there. Okay. All right. Now we got to figure out what are we going to do for our scale. It says 30 degrees. Okay. So why don't I make maybe every other 2 to be 30 degrees? Let's see if we can do that. Okay. So let's see if I can make this be -30, which would be this is 30, 60, 90. Okay, and then I can go 112, 150, 180. Okay. 270. And then we'll get here to 360 degrees. Okay. All right. And we can keep working backwards if we wanted to, but we can just plug them on here. That's negative 90. That's negative 180. All right. So what we need to know, folks, is first of all, we're at our cos x, okay? And we are at our equation, which is y equals negative 1. The thing to remember, folks, is this. This is where people get confused. It reflects the x-axis. So normally cos would start at its maximum, so therefore it's going to start at its minimum. So that's going to be our starting point. So we're going to need to find our minimum value at negative 30. So negative 30 is the start of our box. Okay, and we're going to go to our minimum. And so you take your axis and subtract your amplitude. It's going to get you negative 3. That's where we're going to start. Okay, and then we notice we've got 360 degrees, so by 330 degrees, which is right here, we need to end up back at our minimum. So instead of going max to max this time, we're going to go minimum to minimum. So when you want to take a look at drawing this, sometimes it's helpful to draw the box first so you know how to fit it in. Okay, so halfway between those two, you're going to need to, which is at 150, you're going to need to get to your maximum, and your maximum is going to be 1. Okay, so from this, you draw a nice little curve up and a little curve down. Okay, you're going to keep that going, ladies and gentlemen, so you can get your other point, which is probably right up here. Good. Okay, so there's your graph. Okay, so I always start with my axes. I get my axes drawn, I find out my amplitude, and I use my D value to help me set up a scale. Then I draw my box, and I decide which base function I'm using. Just remember here, this is starts at its max because it's negative. That's where people get confused here. So starts at min because A is negative. All right. Okay, so what do I need to answer? Amplitude equals 2. Okay, the range we'll do in a second, and my equation of access is here. So what's the range going to be? Y belongs to a set of real numbers such that what's our minimum value? Negative 3. Has to be less than or equal to y. That has to be less than or equal to 1, which is our maximum. All right, let's see if we can do one more, ladies and gentlemen. All right, let's finish this last one up. Okay. All right. Sketch y equals 2 cos times 1/2 x minus 45 minus 1, and state the transformations. Okay. So first of all, what's my base function here, guys? My base function is y equals cos x. It'll be written in the formula, either cos or sine. Okay. What values do we know? We know A equals 2. That tells me we have an amplitude that equals 2. If I do a vertical, or if I talk about my transformations, what does that tell me, guys? It tells me we have a vertical stretch of 2, right? Or by a factor of 2. Okay, next letter on our list is K. K equals 1/2. What does that tell us? That tells us that the period equals 360 divided by 1/2. So the period's going to equal 720 degrees. So the K is going to tell us that we have a horizontal stretch by a factor of 2. Okay, because remember, it's 1 over the absolute value of K. Okay? So I guess I should have put down here by a factor of. Same with the first one, by a factor of, okay? All right. Next letter we have here is D. D equals 45 degrees, so that tells us our starting point. What does that tell us in terms of our transformations? That we have a horizontal translation. (45 degrees right). Okay, and our last letter today is brought to you by C. C equals -1. That tells us the axis, which is y equals -1. Okay, so that tells us we're going to have a vertical translation down 1. All right. So taking a look at this, ladies and gentlemen, why don't we just set up our graph? Notice my axis is down a little bit lower, so I'll make it a little bit higher here. Okay. And it doesn't quite matter where I start here. I'll just go down here. Okay. All right. So I've got my axis set up. Let's take a, I've got my X and Y axis set up. Let's take a look at my axes, or my equation of axes. So if we're going to do -1, -2, -3, this can be 1. Draw that in. Okay, to help us take a look at our axis. All right, so what we need to do now is to figure out a good scale. We have 720 degrees we need to go. So what I think I'm going to do is I'll make each box in this case be 45. So I'll just do every other one to make it 90. Because we have to make it smaller in order to fit it in. Okay. So 360. 405. Just a second. 90, 90, 90. I'm sorry, let me fix that up. 90, 90, 90. So if I take 360 and add 90 to it, that's going to be 450. Add some more 90 to it, it's going to be 540. Add another 90, 630. And 720. Okay, add another 90, 810. All right, so that's good enough for this, and I can just do -90, and this pattern will continue. All right. So just remember, guys, that our base is at cosine, so we should be at our maximum at. But we're starting at 45 degrees, okay? So when I start at 45 degrees, ladies and gentlemen, I'm going to draw my box in here at 45 degrees, okay? And I'm going to be starting at my maximum, and my maximum is going to be at 1 because my amplitude is 2 and my axis is at -1. So I'm going to start at 1 up here, which means in 720 degrees, I'm going to also be there as well, okay? So that tells me I need to go 720, so I just have to be 1 past it. So I've got to also be right here again. Okay? So I've got to start at that. I got to go back to my minimum, and my minimum's going to be halfway between that. So if I just do symmetry, should be there. Okay. One more over, sorry, my fault. Okay. So one more over, I was right there. Okay, there we go. All right, so ladies and gentlemen, here's my box. And because it's cosine, I'm going max to max. It's positive this time, so I'm going max to max. Last example it was. Okay, so there's one graph. So all you need to do is just to keep continuing the pattern down, okay? And we know that if you take this and come back down here, it's going to be, let me just see how many boxes I go. 2, 4, 6, 8. So I go 2, 4, 6, 8. Okay? Just because it's symmetrical or it's cyclical, I'm just going to go 2, 4, 6, 8, 2, 4, 6, 8. Okay. And there we go. So there is your last graph, ladies and gentlemen. Okay, now it's your work. Your turn. You need to take the trigonometric paper I gave you already. There should be blank ones on it. And I want you to do these 3 examples. Give it a try. And to check your answers, use a graphing calculator that's on my website or any graphing calculator app you have on your cell phone or on your computer, and double check that. So that's your homework for tonight, ladies and gentlemen. Have a great day. Come and see me, and I hope you'd enjoy drawing your sinusoidal functions.